Alright, now let's talk about the atom. This is the second of my remedial videos. Again, there is nothing wrong with going through remedial stuff. Think of it as review. This is something you've probably seen in physical science or even in middle school, and I may not have time to go through it in depth in class, so this is your review. Parts of the atom, again, is something I hope you've seen before. Whenever we talk about the atom, we're generally talking about the Bohr model, quote-unquote. A guy named Niels Bohr came up with it. And all that means is we know that there's this thing in the middle of the atom. And this thing in the middle of the atom, it has a positive charge. I know that's where most of the mass of my atom is. And then my electrons are on the outside of my atom. And they kind of look like a planetary system, kind of like the rings of the planets around the sun. But that isn't quite detailed enough. A gentleman by the name of Chadwick actually figured out that positive mass in the middle, even though Rutherford said that it's all just this positive mass in the middle, a gentleman by the name of Chadwick discovered that there's got to be something in there. But we already had positive charges and negative charges. There must be something else. So along with protons, there are neutrons in the middle of our atom. So first thing about an atom that we need to know is the proton. This is the thing in the very middle of an atom. It's usually abbreviated like this, P with a little plus sign. That is because the proton has a positive charge. And this is one of two particles that actually contribute to the mass of the atom. Okay, we'll say that here. Has notable mass. And this is also what identifies the atom. What makes a sodium atom different from an iron atom? The crux of that is the number of protons. If you change the number of protons, you change the atom. So we'll say ID's atom. On the periodic table, this is your atomic number. So again, if you change the number of protons, you change the identity of the atom. So please make sure that you are keeping that number constant with whatever atom you are talking about. Later on, we'll get into isotopes and radioactive stuff. But if it's the same atom, it's the same number of protons. Please don't mess with that number. The second particle that is located in the nucleus, as we said, is a neutral particle by the name of the neutron. Since it has a neutral charge, it is represented with an N with a little 0, so it has no charge. Let me put that in nucleus. This is also in the nucleus, and it also has notable mass. So it is part of what helps us figure out the mass of an atom, and that seems to be largely its purpose. If you stay tuned with me when we get into radioactivity, this neutron to proton ratio is what actually allows our nucleus to stick together. Kind of creates that strong nuclear force, that glue that holds the atom together. And whenever we change the number of neutrons, so I can change the number of neutrons. So if we have same number of protons, so same atom, but a different, if we change our number of, I can't write today. That has a special name. It's called an isotope. And it generally has some different properties, does some different things. But for now, I just want you to know that they exist. Together, our protons plus our neutrons make up the mass of our atom. This mass number, or an average of all the different isotopes, is found usually at the bottom of whatever elemental box you're looking at. But only our protons and our neutrons help us figure out our mass number. So, for example, if we were talking about, we'll say oxygen. For example, oxygen has an atomic number that I don't know off the top of my head. There we go. Has an atomic number of 8. You usually see it at the top of the box on your periodic table. Mass number of 16. That is a rounded number, but we'll go with it for now. So, this top number here, this is your atomic number. and your atomic number is also your number of protons. So oxygen has 8 protons. I don't care if it's an oxygen isotope, if it's an oxygen ion, does not matter. If you are talking about the element oxygen in any form, it has 8 protons. This number down here is your mass number. It is composed of protons plus your neutrons. So if I wanted to know how many neutrons this particular atom of oxygen has, I would do 16 minus my number of protons. 16 minus 8 is in fact 8. So an oxygen atom that has a mass of 16 has 8 neutrons. Another way you might see this written, an abbreviation sometimes that you'll see, is like this, where my atomic number is actually on the bottom and my mass number is on the top, just to be confusing. Or written out in words, we could also call this oxygen 16, where your mass number is this number tailing off the back. So that takes care of 2 of our subatomic particles. The nucleus has been spoken for, protons and neutrons, both present in the nucleus. Protons having a positive charge, it's the atomic number of the atom, IDs the atom. If you change those, you change the atom and you just did a nuclear reaction. Stay away from those in general. Neutrons are also present in the nucleus of the atom, have no charge, they are neutral, but they do contribute to the mass of the atom. All that remains are our electrons. Whenever we are talking about, I'll do those over here, electrons, you will also often see them abbreviated as an E with a little negative sign above it like that, since they do have a negative charge. They are located on the outside of an atom. And think of these like a grain of sand. They don't have a whole lot of impact on the mass of the atom. These are what generally define the behavior and the bonding of the atom, or the electrons. So they are a big deal. In particular, the outermost electrons. And those are called the valence electrons. They are a big, huge deal. Again, these are the guys that define the properties of an atom. The Bohr model, which is kind of my whole goal with this video, is to teach you how to do that. I may run out of time. The Bohr model takes the electrons and organizes them into rings. All we can determine initially from the periodic table is just how many there are. And for a neutral atom, that means that our number of positives has to equal our number of negatives. So with our oxygen atom here, if we're talking about a neutral oxygen atom, I have 8 protons, means I must have 8 electrons. If we're talking about an ion, so an ion is an atom with a different number of electrons. If I'm talking about a negative ion, so ion just means different electrons. That means that I must have less positives and more negatives. In this case, oxygen takes a -2 charge, which means that I can't change protons. I still have to have 8 of those. But in order for my oxygen atom to take a -2 charge, I must have 2 more electrons. So 8 plus 2 is 10 of those electrons. If we were to do a positive ion, that means I need to have more positives and less negatives. It doesn't do this, but just for sake of argument, let's say oxygen took a negative or a +2 charge. It says more protons, but remember what we said about protons. Protons ID the atom. So if I said 10 protons, all of a sudden I'm not talking about oxygen anymore. Now it's neon. So I can't change my proton number. Instead, I'm going to have to lessen my electrons. Ordinarily, I have 8 with my neutral atom, 2 less would be 6 electrons. So, let's see. Let's do a couple more examples of those, and then I'll do Bohr model in the next video. I'm going to run out of time. So, if we were to, say, talk about the element phosphorus. So, phosphorus's box on the periodic table looks like this. So, if we wanted to know protons, electrons, and neutrons for this particular atom, right off the bat, we should be able to get protons and electrons pretty easily. Since we're talking about a phosphorus atom, that means that my atomic number there tells me both protons and electrons. Now for neutrons. This number is a decimal, which may throw you off a little bit at first. But remember that we can have isotopes, which is the same element, so phosphorus, 15 protons, but a different number of neutrons. So this number is actually an average of all of those different isotope masses. So we're just going to round to make our lives easy. So this will round to 31. So this number here is protons plus neutrons. I just want neutrons. So I'm going to do 31 minus 15, and that should give me, I do believe, 16. Now let's say we want to do one of those isotopes that I keep mentioning. Let's say something like carbon 14. This number here is your mass number, so this is your protons plus neutrons on the periodic table. Carbon's box looks like this. Now, I have replaced this number. For this particular carbon atom, I'm talking about a mass of 14, not 12. But my protons and electrons will still be calculated the same way, off of my atomic number there. An isotope, like this guy, only changes your neutrons. That's it. So 14 minus 6 gives us 8 neutrons, where a regular carbon atom would only have 6. So for an isotope, only neutrons change. Last but not least, let's do an ion example. For example, let's say sodium plus 1. This is the sodium ion. It has a +1 charge. Sodium's periodic table box looks like this. Let's say, once again, I want to do protons, electrons, and neutrons. Protons do not change. It is always this atomic number right here. Since this is an ion, all I'm going to change are my electrons. So for an isotope, we change neutrons only. For an ion, we change electrons only. So let's go ahead and talk neutrons real quick, since that's ordinary. So let's see, 23 minus 11 is what, 12? Now, were this a regular old sodium atom, oop, you can't see that, I apologize. Were this a regular old sodium atom, it would have 11 electrons to counteract this 11 protons. But since this is a positive atom, I need more positive and less negative. But remember that we said we cannot change that number of protons. I have to leave it the same. So that means all I can do is change my electrons. I need less electrons. How many less? 1 less. 11 minus 1 is 10 electrons. So I hope that gives you a window into how to calculate the number of protons, electrons, and neutrons for a given atom. In the next video, we will go into how to draw this in a picture and actually put the electrons on their appropriate rings. See you then.